We're going to just do a very brief run through of why Dell are so into sponsoring this event. And again, thank you, Ross, for calling that out. I remember about 3-4 years ago being at a conference called World Hosting Day. It's where a lot of people in the hosting business get together and swap ideas and pay a lot of money to be there, but build their network, and the vendors tell them how wonderful the vendor's product is on that day. And this tall guy bounced up with our director of innovation at the time and said, "Hey, I'm the CEO of DreamHost. I'm thinking of doing this sort of thing. Are you interested?" I looked at my director of innovation and went, "Are we interested?" He said, "Do what you like, guys. You're Europe. You can run your thing." We're Europe, Middle East and Africa. Actually, that really throws our Texas colleagues. And for any Texans in the room, that's rest of world. But then again, so is rest of US for any Texans in the room. We know that. So oh gosh, a year later at the same event, we had the Ink Tank guys guesting on our booth. And the year after that, they were also guesting on our booth. And then they announced the Red Hat acquisition. I think Steve will talk about what we do there. We think this is brilliant. Now, it was certainly not there in day one. But one of the things I wanted to just cover on this is...
Keep up to date.
So the first thing is, okay, why are Dell interested in Red Hat Ink Tank Ceph? There's an interesting statistic doing the rounds on social media. I think it's IDC said Dell were #1 storage in terms of the volume of storage we've sold. Some people say, yes, but you sell a lot of disks inside laptops and desktops. And yeah, I get that. Don't know how IDC did this. But it's certainly through some of our competitors at the more classic EMC and NetApps. Hang on, what are Dell doing at #1? I kind of argue back to you guys and to anyone who's prepared to listen. It's because we embraced products like Ceph. This is great for Dell. You can buy support from Dell. If you feel the need to buy Red Hat support, you can buy that from Dell. If you've got a Dell credit account, and Dell own a bank, so we can do all sorts of smart things with that. You can buy services and training from Dell, and that's really good as well. And of course, you can download it for free. And I'll be brutally honest with you, we as Dell are not that worried if that's the route you choose. That is not a bad route. In fact, we'd encourage you to start with that route. And Steve will talk about why we'll encourage you to do that, because again, being #1 in storage and recognizing that storage isn't necessarily a dirty, great big array hiding away behind a mainframe, that to use a Dell phrase, the economics of storage have changed a lot. Steve will go into that. But what would Dell bring besides hardware and an option to sort of transact with us? Well, one of the things, this is an OpenStack slide, one of the things we're really good at is mobilizing our channel partners and our sales teams to really get behind something and help, I don't like the word evangelize, but spread the message that there are alternatives to traditional, and spread the message that you might not be the first, but you're still innovative and you're still bringing business value to your business. Now, again, going back to Ross's point, a bullet point that says false dichotomies can be tough if you're an executive. So I'm going to check how many CEOs and how many marketing directors are in the room. We have one who put the bullet up, false dichotomies. Thanks, Ross. So this is what Dell does very well. We take something that is inherently complex and we shrink it down so that our colleagues who work in finance, are any finance people in the room? I've really worked this slide hard for CEOs, marketing and finance, and we spent a lot of money on this one. This is what we're very good at. That's how we sell it. It's inherently complex, but that's how we help everyone understand in the Dell sales engine, in our channel, whether it's OpenStack, Ceph, it's stuff, and you, Mr., Mrs. Executive, get stuff. And 9 times out of 10, we have a brilliant moment saying, you will be able to get more than your competition for a lower price. It's a double whammy. So just before I hand over to Steve, this is a fantastic event. We sponsored the Frankfurt event. We love Ceph because it allows us to say to customers, you will be able to do more for less. It's absolutely what we're about. So congratulations for spotting that. I'll be back in a minute because we're going to throw some ideas at you, but now I'm going to hand you over to the brains of the organisation. Follow him on Twitter, Mr. Steve Smith, ladies.
Thank you, Paul. Now, applause for Paul. Yeah. So, yes. Good morning, everybody. We're running early, which is really unusual. So that's cool. It means, yeah. Which button did you press? Good, cool.
You're on your own.
I'm on my own. Thank you very much. Yeah, I appreciate that. So I'm Steve Smith. I'm not a storage guy. I have got a suit, so you can tell I'm from a vendor, like Paul. Very similar suit, but I do have a pocket full of pens, so I am a techie. Okay, so and they're all different colours. I'm actually not. As I say, I'm not a storage guy. I'm actually in the HPC business at Dell, the high performance computing business. Been doing that for a number of years, and Paul asked me a couple of weeks ago, actually, when we thought about this event, if I'd come along and talk about performance, and I'm going to hopefully bring a slightly different viewpoint to it based on what I've done in HPC over the last few years. So we'll see how it goes. I'm also not a Ceph expert, so if you've got any tricky questions, don't ask me. You probably have more knowledge of Ceph itself than I do, but I think there's an approach that I use, which hopefully will come through in the next few slides, that help you to maybe take a slightly different look at how to get the most out of what you're running this stuff on. I'd also like to thank Kyle and Mark at Inktank, because I stole a lot of their information off their website. Okay, so consider yourselves acknowledged. So I think that, this is a fairly standard business as usual sort of slide here, right? If you're going to put a big thing in, be it a storage system or a new VDI system or whatever, you need to plan it, and you need to think about what your business objectives are, what your sizing is going to be like, and so on. In particular with storage, we need to think about traditional things like IOPS and throughput. In the HPC business, we're mainly concerned with very fast throughput, and we use Lustre and GPFS and big file systems like that, and we typically deliver gigabytes or tens of gigabytes per second of storage throughput to the cluster clients. Okay, and imagine if you've got 1,000 processing cores all working on a model of a Formula One race car. They all access the same CAD file. It's been meshed and all that sort of stuff, and they've all got to do their little bit of stuff, and then they've got to write their outputs out. We need a very high performance file system. So Ceph is clearly not in that place yet, right? But it was quite interesting that the original funding for Ceph was part of a DOE grant, I believe, for an HPC system. And I know that Ceph has been run at one of the national labs on a DDN system, which is a fairly expensive proprietary piece of kit. I think it was an SFA 12K, which is rated at 12 gigabytes per second, and they got 10 gigabytes per second out of it using the block device. So that was quite good, actually. So from that point of view, it's good. As a pure file system, it ain't. But hey, we're not here to talk about that. So clearly we need to think about what we're going to store on it, why we need this thing in the first place, what's wrong with what we've got, and have some envelope or boundaries that show us what we're going to do. We also need to understand some architectural things around how we're going to implement Ceph, which bits we're going to make use of. Are we going to go for absolute reliability, or are we really doing a test or based on lowest cost to try this thing and try it with a few tame users and so on? Things like, if we've got a multi-rack implementation going on, do we want rack failure as a domain, or do we want data center as a domain? And how are we going to plan for those things? Because Ceph can, and we have customers already doing it, store multiple petabytes across multiple sites. And we need to be able to plan that and work out the best way of architecting that overall system to make sure that what we end up with suits our requirements and delivers what we need. There was one webinar I was listening to yesterday, actually, when Mark, I think he's a CTO or something, was talking about data redundancy and durability, and he made the comment that 3 copies equals 8 nines availability. That's 99.999999%. That's less than a second of downtime a year. I don't know. I thought I'd put it up there and ask you lot to check it out. But anyway, that's what he said. And beyond all that, when we're looking at what we can tune, there's a multiple set of things to tune. There's stuff we can tune in Ceph. There's stuff above Ceph, the application end, the client side and all that sort of stuff. And then there's the stuff underneath Ceph, going down to the hardware and the TCP stack and everything in between. So we don't just restrict ourselves to tuning Ceph. And in fact, I'm not going to talk about tuning Ceph at all. If you want to tune Ceph, there's some very good videos or webinars on the Inktank website that give you some pointers in that. And they're only about 10 minutes long, so they're quite nice, short treatments of things to look at to get the best out of Ceph. The other thing we need to do is understand what we're looking for from our workload perspective, what sort of apps we're going to run, what sort of users we're going to have on there. These two sides are not mutually exclusive. You can equally have a high IOPS requirement or a high memory bandwidth or high storage bandwidth requirement and very high storage requirements. Right? So they're not mutually exclusive, but you do need to understand where you want to get to with this stuff, because that might affect how you start deploying in the first place. I won't dwell too long on that. That is another slide I've stolen from Inktank. You can go get it on the web. And this one is also another slide I've stolen. Just to refresh on the architecture, I'm really going to look at what we can do around building the storage servers, the place where you host the OSDs, and the monitor node. Okay, you only have 3 or 5 of these things typically. They're quite small, they don't do much, but they're very, very important. So look after them, and the gateway. Okay, those are the things I'll concentrate on, and the back-end network as well. Clearly, we could spend days on performance tuning and looking at this stuff. So in a half-hour, very fast overview, you're not going to get a great deal of depth, but hopefully I'll give you some pointers, and hopefully look at some things that aren't considered normally in this sort of area. The thing I do is try and understand what the software does. So in this case, let's have a look at what Ceph does from a write point of view. I'm a client, I want to do a write, and I want to do 3 parallels, very simplified, right? So I've got this 3 megabyte chunk of data, this object. I say, right, I'll split into 3 1 megabyte chunks and I'll write 3 times parallel. So my client, I run crush. It tells me where to put the stuff. It says put 1 on the green, 1 on the blue, 1 on the yellow, and off I go. And as a client, that's it. I now wait. All right, because it's essentially a synchronous activity. Now I'm going to wait for an acknowledgement. Okay, until all those 3 writes have completed. If we just look at the blue one, to make it simpler, the primary copy, in this case of this particular third, goes here to the blue one. The blue one then looks up at his crush map and all that stuff and says, I've got to make another copy of this, and it's going to go there, bottom left. So I'm going to now send my write off through the back-end network to this copy here. And of course, if I had 3 copies, there'd be another copy over here somewhere as well. And I will not acknowledge to the client until I've got the acknowledgement from my copy. Okay? So that immediately means that if this is a multi-site system, I could have some serious latency issues there. So we need to consider those sorts of things and where you're placing your copies and so on. I've also got to write the journal as well. Actually, the journal is written first, then the data, then the primary takes the data and writes its copies. Its copy then acknowledges back to the primary then acknowledges back to the client, at which time the client now has acknowledgement and will continue. Okay, so bear that in mind as we go through.
Can I ask a question while you're doing it?
Yeah.
Is that the same for erasure encoded copies? So it has to create...
I actually don't know. I haven't got that far yet. I don't know. We can ask that a bit later, and I'm sure someone here will know. But that's a question we can ask later, yeah, about erasure encoding. I also want to understand what the makeup of the hardware is that I'm running on. Okay, and this is a very standard, very simplified 2-socket Intel or AMD server. We'll come back to this a bit later on, but I've got 2 sockets there, got memory attached to each socket. Bear in mind with processors these days that the memory controller is on the processor socket. Okay, so memory is a different distance depending on where you're running, and that's something that's often ignored. Also, PCI is generated by the processor package itself. So it's not shown on here, but that socket has its own PCIe lanes, right? So we not only have NUMA, non-uniform memory access, we have NUNA, non-uniform network access, okay? Because if I'm on this socket, my process is on the top socket there, and I'm accessing, whoops, fall off the stage, this NIC, I've got to come through there. So I've got a longer length to go. So just these are things just to be aware of. You might get, performance degradation over time because things are going in the wrong places, and we need to be aware that we've got to look at these things. I mentioned multi-site before. Covered that piece really. If you're replicating from your primary to a secondary or tertiary off-site, your latency is going to be quite long, and your client is going to wait. Now the client can, actually there are technically two acts. There's an act that says I've got it in memory, and there's an act that says I've got it in disk. And you can set it so that you can get the memory act and operate on that. You can even decide to ignore the act if you want. So it's not strictly synchronous. But do be aware of that your application might time out. Yeah? If you're running a web interface, so you're running HTTP as the inbound stuff, and you're using gateways, you can federate the gateway. So you have separate multi-site clusters which then work through the gateway rather than treat them as a completely homogeneous cluster. Okay, and if you're doing RDB, you write backup, then you can treat your primary cluster and your secondary cluster as synchronized replications, if you like, through various replication agents that you can use there. So you don't have to treat them all as a single Ceph cluster. You can deal with multi-sites in a number of different ways. So let's have a look at the recommended configurations for the storage server. These are from both the ceph.org website and Inktank's website. They're a little bit out of date, I have to say. Okay, if you look through these at first glance, you think, well, anything will do this, and to an extent, you're right. Actually, you can throw anything at this stuff, and it'll run. 1 core gigahertz per OSD is the recommended minimum. That means if I've got a 2 gigahertz core, I can support 2 OSDs off that core. Okay, so if I've got an 8-core processor running at 2 gigahertz, that would support theoretically 16 OSDs, 16 drives. Okay, so an OSD equals a disk drive in general. Okay, slightly less for AMD. AMD cores tends to be about 60–70% the performance of an Intel core these days of that area. Okay, and of course, if you've got 2 sockets, then you can get even more OSD support in there. Typically, you don't, because you don't have enough space, or you don't want to overload the disks in a particular storage server. Okay, you want to limit the number of disks you have in a storage server if you're interested in serving storage in a high performance manner. If you're in an archive situation or a cold storage thing, then you can have as much disk as you want behind a single node. Okay, and we can do 3 petabytes in a rack behind 3 servers, right? This is not difficult these days. But if you're in a more production, high frequency of usage environment, then you don't want to put too many disks behind a particular storage server, because you're just going to funnel all the requests through that single server. So spread them out. Okay, tends to be around 12 drives per storage server to be the optimum. That means you want 12 cores. You have to go quite low down the processor stack to find a 6-core device these days, and if you stick hyper-threading on, well, you could support even more. But anyway, we'll come back to that. So, what else? SAS or SATA doesn't really matter. I prefer myself nearline SAS if you've got a choice and you can afford the slight improvement in increase in cost. It's literally about 10 quid or something. Nearline SAS have the advantage that they can re-queue much more efficiently than SATA, so the actual disk writes are a lot quicker. And unlike RAID, the size of the disk does not matter. 6 terabyte drives are fine, because you're splitting this thing over 100 or 200 placement groups, and those 100 or 200 placement group disks are all helping in the rebuild if you lose a drive. Okay, so you're typically 10 to 50 times quicker than a RAID set rebuild. You're not into days of rebuilding a 4 or a 6 terabyte drive, you're into minutes. Okay, so actually you can use big disks. Talking about the processor there, let's have a look at the current Intel stack. Sorry, it's a bit fuzzy. This is the Haswell, so this is the Intel Xeon E5-26XX version 3, okay, V3. It was released in September, and if you just went out and bought a server today, you're most likely to get one of these. In the HPC area, we tend to go in the top of the advanced stack there, that top left block, or in the top of the segment optimized stack there. For this stuff, we already said we need a gigahertz per core per OSD, and we're only looking at 12 drives sensibly in an operational quite high frequency access system. We're really looking at 6 core or 8 core devices down here. Benefit, they're nice and cheap. Okay, these were expensive, they're now real cheap, they're about $200 a processor or something, so they're at the lower end of the price performance curve. They're more than adequate, they're fairly low voltage, 85 watts, they've got turbo boost, so you can get extra speed there if that helps at all. They've got decent QPI speed. The basics clock down quite a bit in terms of their overall throughput because the QPI speed and the memory bandwidth is all lower, and these things do impact your perceived and received performance. So these are about the best ones to go for. Okay, E5, 2620, 2630, 2640, somewhere in that area. Those are the, what I think are the recommended processors there. I mentioned NUMA before and memory. It's unbelievable how many people do not understand how to buy memory for a server. this is my own personal hobby horse. Okay, really annoys me. For about the last 5 or 6 generations, the memory controller has been on the processor package. Okay, so there's one socket with 8 processors in it, there's another socket with 8 processors in it, standard 2-socket Intel server, also AMD, same thing applies, slightly different numbers. Also on there is a memory controller. Okay, so the memory, these red lines coming out the sides, is attached directly to a package, and there's a ring in there that you don't see which connects it to the processor core. So the cores access memory by going onto the ring, let's take C7 there, and onto one of those memory channels or more. Now the memory bandwidth available theoretically for a current generation Intel processor running at 1866 mega transfers per second is about 60 gigabytes per second theoretical. Okay, it's delivered by each of the 4 memory channels. Each one contributes a quarter. So if you buy a machine and you only put 2 DIMMs in it, one there and one there, you've lost 75% of your memory performance. 75%. Okay. The number of people who buy 6 DIMMs or 12 DIMMs or 3 DIMMs just is always buy 8. Okay, 8 or 16. Right, make sure every channel is populated on each socket. If you don't do that, you're losing performance. You might think that doesn't matter in a storage environment. Well, you're running TCP as the back-end protocol here, right? You've got a lot of memory copies, you've got a lot of stuff coming in and out, you've got all your inode stuff, you've got your D-entries, everything in memory. So make sure you don't compromise your system by buying the wrong memory. End of thing. Okay. Got it? Okay. The other thing, not quite as important but still fairly important, is because we're in a NUMA mode now, if my process, my thread is running on C0 up here and my data is over here, right, it's got a longer way to go. And of course the operating system is a bit of a pain in the arse, because the operating system says every time I get an interrupt, right, you get off, go in the queue, wait till your interrupt's serviced or whatever, I'll put someone else on there, and I might put you back somewhere else. So my thread might be running on C0 there, and my data might be on the memory attached there. I go off, and the operating system in its wisdom puts me over here, my data's still over there, all of a sudden I've got a longer path. So it's quite important to pin these things together, right? So just pin your process and your data to the same socket, life will be wonderful. interestingly, because we typically are saying we only need sort of 12, maybe 16 drives on a node now, we've got to, especially if you put hyperthreading on, you could say, well, we'll just let the OS float around and take whatever spare cores are out there. So that's another thing to think about. Finally, on memory, the memory market has changed quite considerably over the last couple of years. The current generation of processors now use DDR4. DDR4 memory DIMMs are not small. They start at 4 gig. Right? The memory market, the actual memory modules are built in 4 gigabit bits now, rather than 2. So the smallest amount of memory you can get is 4 gigabytes. If you're populating in 8s, right, you got 32 gigs. So your minimum memory on a system is 32 gigabytes. However, that's single rank. Single rank is somewhat slower than dual rank. My advice is, for the small increase in cost, go for 64 gigabyte, 8 gigabyte DIMMs. Okay? And then you don't have to worry about it in the future. If you go to erasure coding, you're going to need more memory, more performance from the processor anyway, so just do it. Okay? So your standard is a 2620, 2630, 2640 V3 processor with 64 gigabytes of DIMM for your storage node. Yeah. Anyone want to argue about that? No, good. No. Here's an old one. This is Dream Objects, part of Dream Hosts. This was, what, 4 years old, I think? 3 or 4 years old. Just to show what they did then, and it's still actually fairly relevant today. This was built on AMD stuff. We still do these products with slightly updated processors, but they've got 3 petabytes of storage at this point in time, with 3 copies, so a petabyte of usable, running on AMD 6-core processors there. Nothing really to say on that other than bear in mind a few simple principles about NUMA and memory configuration and so on, and we should be fine. Okay. How are we doing? Okay. The gateway server. The gateway does a lot of checksumming. CRC32 out the front, okay, and MD5. So CRC32 is now hardware encoded in the Haswell product. So if you go for the latest generation processor, you'll get a speed up for your gateway. Okay. Remember, the gateway speaks Swift and S3 out, and it speaks Rados in. So it's doing that translation, it's doing that reformatting and all that good stuff. 64 gig again, that's really the least memory you should buy these days. Okay, if you don't want to compromise performance unwittingly. 2 separate 10 gig NICs. We'll talk about networking very quickly in a minute. File handles. I picked this up actually only yesterday. Apparently the default when you set up RGW is 100 file handles. You need like 4,000. So change that one. Yeah. And if you've got lots, if you've got a big system, then you'll need to put in some form of load balancing, either with front-end load balancers or through, ECMP networking and all that sort of stuff, just to make sure that the sessions stay up if a gateway fails and so on and so forth. Quick word on the cluster monitor. You can mix and match for small systems, but ideally the cluster monitor it's the most important node in there, right? Without the cluster monitors, you only need 3 of them. So don't necessarily skimp. They're fairly lightweight, but they need to be there because they're the people that keep the map up to date, and they tell the OSDs and the clients and the crush algorithm where to place stuff. So without these, you're dead, right? You need 3 at least, 5 maybe, sometimes 7 if you've got lots of failure domains. You need to make sure that they're placed within a failure domain so that you always have at least 2. Okay, won't operate with 1. Has no one to ask if it's okay to do things. So just, yeah, fairly cheap, but make sure you've got redundant power and a RAIDed disk set. That's it. Okay. All very, very quiet. Networking. Spent hours on this, but I'm not going to because I'm not really a networking guy either. For front end, you really want 10 gig. So, OSD node, the storage server is going to have 4 networks. Okay. The simple ones, 2 gigabit networks, IPMI for remote out of band, maybe 100 base T. A Ceph management network, gigabit. and then 2 10 gig networks at least. Okay, one for the front end, which communicates with the client, and one for the back end. The back end is quite heavyweight. If we go back to my earlier diagram where you've got the client doing the writes, right, that's the 10 gig client front side link. The back end is where all the stuff happens, because the primary then uses the back end network to do all the replication. At the same time, because it's a big system, you're going to have a failure as doing all the rebuilds and all the other stuff. Right, so the back end actually needs to be at least 10 gig, and preferably, if you can afford it, stick a bit extra in there. Right, so pay more attention to the back end networking than you do the front end. They don't have to have completely separate switches, so you can use 48 port 10 gig switches or whatever and use the same switch. Just make sure your failure domains are okay. Right, if you lose the front end, then you know, it doesn't matter if you use the back end, I suppose, because the node's dead anyway, right? But just remember that the back end does a lot more work than the front end, and if you can go to something like a 40 gig, I mean, we use Mellanox stuff, I know Mellanox are here later, we use Mellanox Ethernet stuff for 40 gig and 100 gig Ethernet, okay, really good, very cheap. Does the job, works really well, and you can also go to InfiniBand if you so wish. We use InfiniBand a lot in the HPC environment for storage area networks, as we call them, or parallel file systems, Lustre and so on. That again works well, but for many people it's a new technology. You don't want to go there. Stay with Ethernet, just use the fastest you can. Okay, just a couple of adverts. We've got some product. Of course we have. The only thing that's free with Ceph is the software, right? You've got to run it on something, and you've got to pay for support somewhere, either internally or externally or both, right? So just, you know, it's only the small bit that's free. Of course we have a bunch of stuff, and there's just 3 examples here, starting at the bottom for a monitor node, something very low cost, a single or dual socket AMD box with a couple of 1 terabyte drives in there for the monitor logs. They do a lot of logging, these things, yeah, so make sure you don't skimp on drives in there. 10 gig to get onto the network, of course, and then the top one there, we call it the Power Edge R720 or 730 now. The 720 is a Ivy Bridge, the 730 is the latest Intel Haswell processor, V3. That will take a whole bunch of 3.5 or 2.5 inch drives. There's a version that takes like 24 disks in it, if you want to go that far, all in a 2U, so it's quite compact. And takes up to some ridiculous amount of, what's 2432s, 768 gigabytes of RAM, if you want it. And we also have this very dense product here called the C8000 range, which is basically a chassis 4U high, so what's that, 7 inches or thereabouts, and you can slot 8 devices in there. Okay, so they're half of you each, same as a 4 in 2. But the benefit of this one is you can have compute, you can have GPUs if you're into that sort of thing, and you can have storage. So you can attach your storage through a sled that goes in and has like 12 drives on it. Okay, so you can get your ratio of disk to storage. You can get your 12 drives per storage node in essentially a 1U. Okay. And we also have a 1U box that will also do 10 drives in 1U, or 24 2.5. So quite a variety of packages. It is packaging, okay? The motherboards are almost the same. The processors are the same. The memories are the same. The NICs are the same. Just the way we package them up and shape them and put things on the front so you can read what they're saying. So we have got a wide variety of stuff. Quick word on mixed use. Ideally, yes, dedicate hardware to monitor, to OSD, and to gateways. You can mix and match, and obviously in a test environment, that's the way to do it, to reduce cost and check functionality at least. But don't make performance evaluations from a test rig, unless you're doing it for testing purposes, for performance evaluation purposes, in which case make it a proper system the way you would deploy it. Yeah, and that's just sensible. Yeah, that's about all to say on there. And if you're into big archival or big cold storage use cases, then I mentioned earlier we can do 3 petabytes in a rack. Well, this is it. You take one of those. Actually, you take the smaller brother of that. It's a 1U box as the storage server, and you attach 3 60 drive bays to it. That's a total of 13U, 3 of those in a rack, 39U, plus a bit for the rack switches. And that is over 1.2 petabytes of raw storage in a rack, yeah? No, sorry, 3 petabytes. Yeah, sorry. Got the 6 terabyte drives, yeah. So that 3 petabytes of storage in there. You still need to put the gateway nodes in that somewhere, but in terms of absolute highest density storage, that's one of the best available today. Finally, for me, before I hand back, just in general, overall things to consider. We don't need sophisticated componentry here. We use JBODs or just SAS HBAs rather than RAID cards, except on the monitor node. Okay. In fact, some of the cleverer RAID controllers, if you set them up and you've got your 12 drives in your storage server and you've got a clever RAID card in there and you lose a drive, it won't know what to do with it. Because you've got 12 RAID sets, all striped, and there's one drive gone. Where's the rest? It just falls over and collapses. So buy the cheapest RAID controller or a SAS card, right? That's all you do. Or use the inbuilt SAS or SATA, okay? Don't go clever. Keep the networks as flat as possible. There's a lot of east-west, back-forward traffic here, so it's not the typical sort of structure there. Spend more effort on the back-end network than the front-end network. And think about, certainly for large deployments, where your failure zones are, because that all goes into the Crush algorithm, so Crush knows where to place stuff, right? So you have to tell it what your architecture is, and then it says, okay, you're going there, there, and there, and then I'm resilient. Good. Paul.
Thanks very much. We're going to run through a couple of slides, and Stevie's going to jump in anytime he wants, because we have a pet theory. We have a pet theory that, and whether this is research data because you're in an organisation that does research, whether that's life sciences, whether that's public sector, whether you're university, whether you're a big government lab, or whether you're oil and gas or whatever, the principle remains: we believe the same. We believe it remains the same. You've kind of got at the top stuff you publish or gets published, and depending how you choose to publish, you may there's not enough people of my age in the room to understand this. It's a really amazing piece of technology. Steve showed it to me recently. It's Paperwhite.
There's
really
one here.
Easy search.
There's one here.
Can we see it?
Yeah, it's called this.
This is stunning.
Display.
I suspect this may be the future, but you can publish information on paper. It's printed and bound and delivered to things called libraries.
There you go.
I know. I was like that. Well, no. How do you search it? There's an index at the back. At the back?
Yeah, distributable.
Yeah, data exchange. It's just stunning,
Fantastic
isn't it?
stuff. Awesome.
There is that. So you can publish that way, or you can publish a video diary or a vlog or life log, anything you want. Meanwhile, the sort of pre-publication will sit in there, and we call this digital other. That might be the collaboration that happens where you, if you're on Facebook or LinkedIn, you only want your friends to know about that. You don't want your intellectual property kind of up there published electronically or whatever. So we feel, irrespective of what sort of research you're doing, this is kind of the digital life of that. And there is a lot of drive to store as much of that, because particularly now with researchers, you'll see, I think this is a really cool thing, that researcher type A and researcher type B may be from completely different domains, but that does not mean that the research they're doing is mutually exclusive. They can start to say, oh, you've discovered that, I didn't know that, that has an implication on what I'm doing. One might be a materials guy, the other person may be doing pure math. And more that should be encouraged, because that's how genuine new discoveries can be brought to bear. But then you get the naysayers kind of doing this is great, but there are all of these problems with sort of holding this data in a digital library. And you know, we've thrown up some of the challenges our customers and users have thrown to us. And one of the things we want from you guys are, what are the challenges? If you've got a digital store here, a library, these library things might catch on, I don't know. You know, the challenge would be to search it. How do you secure it? All of these challenges are absolutely real, absolutely imperative to be able to secure your pre-published information. If you're in a drug research environment for a life science company, that could be the difference between the company failing and succeeding. So the security is very relevant, but at some point you want to publish and actually it isn't so secure. In fact, you want it read. You don't want to make it so secure. I mean, is there anyone else in this room that when you have to register for a download document, you don't bother?
You do have to register on the Ink Tank site, by the way.
It's
just so you know.
I know I'm getting ancient and can barely walk and talk now, but yeah, register for something free. I don't think so. Next. Got the attention. My cat has a longer attention span than me. So to publish, you need to be quick. So you've got this dichotomy.
Got it in there, well done.
Of how you secure what you need to secure and how you publish and encourage publication and sharing and collaboration and everywhere in there. And that's just security. And if there are any security guys in the room, gals in the room, you'll kind of now start to come at me, and please do. I'll give you energy in exchange for your thoughts on that one. Now, in true open source style, absolutely stolen the next idea, because the challenge with all of these people here saying, stop storing it, we've got to figure this out, is that I stole this from Finding Petroleum. You're holding a tin cup under Niagara. And just, I won't say the individual's name, he was an astrophysicist, who said the thing is, when you press the button and the satellite starts transmitting, that data starts coming and coming and coming.
Yep.
Now, that's fine if you're a physicist and you've got a satellite broadcasting data to you. Now, I work for Dell, and our technologists do brilliant things. They do teardowns of every product they have so that our channel partners and things can fix them. And they shoot that on a little flip cam. They shoot it in their little rooms, and they show, don't take that screw out, you can lift the whole thing. It's just really basic teardown videos. And that just keeps coming. The volume of data, we know volume, variety, velocity, we get that. It keeps coming. So our pet theory, and we want you to shred it if it's wrong, tell us we're geniuses if it's right, steal it and make it your own if you feel we're going the right way. What we want is our volume, variety and velocity on this. Here's your key. I told you we were fans of this. The conversation we have with people who have this problem is, while you have that tin cup under Niagara, and I mean this respectfully, you go to your storage salesperson who will tell you, put it on an array, and they will put I nearly said dollar, I do apologise, a euro or a pound sign next to that, and you'll go, nice. But I'm talking about a bit more than that. And you know, as the salesperson leaves the room, they're going, ka-ching, I'll buy a new boat. But they've just talked your budget so ridiculously high, it's not going to happen. Then our friends at Ceph came along and went, we designed this from scratch for petabytes. Suddenly, you're kind of a bit more than a tin cup under Niagara. Ceph are our friends for this. And for the benefit of the tape, other alternatives are available. But this is our view. Ceph is the way to go. And the longer you have to hold that data for, the more likely it is you'll want to put it on spinning disk. You could put it on tape, your call. If anyone in this room works for 3M, good on you. If anyone in this room wants to put all this stuff on tape, go talk to 3M and watch their stock price rise when you say how many tapes you'll need, how many times you'll need to rewrite to those tapes, and talk to some of Dell's backup guys about how many of those tapes will rot the data before you need it back. It's no shock. Ceph on spinning things will be able to serve the data up a lot easier. That's how the Bay Area guys do it. We use Google every day, guys. We know this is in principle sound. We believe there's an OpenStack layer in the front that gives a bit of access and a bit of cloudiness to it. Other options are available, but again, we think that's a neat fit. We think there are things you need to do that may be proprietary. Is there going to be a shock and horror in the room? And I say, with policy control and governance and identity management, you could talk to the Dell organization about all of those. And shock, horror, it's highly likely that we have a proprietary product that we can ship you for that. It's also highly likely that some of them are award-winning and best in class. Of course, that's not going to surprise you, because when the software here is free, I've got to make some money somewhere. Come on, guys, play the game. But our key point on this one, and it's kind of the one, again, we'll give you energy, shred us if we've got it wrong. If we're missing something, please share with us. It's the critical message to all our customers, just do it now. It's start now. Start storing it now. Because, and I don't want to go back to the slide with all the balloons on it, if as an organisation, I mean this so disrespectfully it's untrue, you allow your organisation to lock itself down and start to worry about all of the blobs that were this side, back to Niagara, the data will keep coming. Your problem will get bigger. And some say, oh, it'll get bigger by the day. I got some really bad news for you. There's plenty of slides. Go on SlideShare and see how much data is created a minute. That's the scale of the problem. It might not be your problem, but whatever the storage problem your organisation has, it will be factored by that, and it's going to get worse. So start here.